be going over dimensioning, and we're going to be going over basic rules of dimensioning because you're going to be starting doing that on AutoCAD pretty soon. So hopefully I can give you like an introduction, help it make a little more sense once you start doing it. So if you can all look at your rules, we're going to go through those, and I'm going to try to explain them as we go along. And then at the end, what we're going to do is we're going to use this piece of paper. And after we've gone through all the rules, I'm going to give you the opportunity to come up here and show me like where one of those rules was or was not followed, which rule it was, and then you need to explain like how it was followed or how it was not followed. And if you have any questions, feel free to ask. If you need clarification, feel free to ask. For everyone that volunteers and participates, for every answer that's correct, you will get a piece of candy. So yeah.
That's fun.
So the first rule is that dimensions should not be duplicated or the same information given in two different ways. So this is talking about when you guys were doing your top view, front view, side view. If you give the overall width in the front view, you cannot give the overall width in the top view. That's redundant and it just makes your picture more messy, and it's like giving the same information in two different ways in two different areas. So that's basically what it's saying not to do. If you have circles that are the same dimension all throughout, you don't dimension every single circle. Instead, you're going to dimension one circle and put a note that says this dimension 4 holes or whatever. So that's what number 1 means. Is there any questions? Okay, so number 2 is that there's no unnecessary dimensions that should be used. So only those that are needed to produce or inspect the part. So on here, for example, this could be like considered an unneeded dimension depending on who you ask, because you could do the 11 and the 22 and then take the overall dimension, do the math, and figure out what it's supposed to be. So sometimes on your drawings that you get in the little pictures, you'll be like, well, what is this dimension? Or I don't see it, or da-da-da-da-da. And you have to do math because it's not given, because there's enough information there for you to get it on your own. Does that make sense? Because when you're like, the reason for this is if you're working in a shop or if you're actually like using a drawing and working off of it, it needs to be as like neat as possible. It needs to be clear and concise so that those that are reading the drawing to produce the part or whatever it may be are able to do it clearly. 3, dimensions should be placed at finished surfaces or important center lines. So basically, don't dimension hidden lines, don't dimension like places that are like continued in another section. 4, dimensions should be placed so that it is not necessary for the overseer to calculate scale or assume any measurement. So that's why I was saying right here, it depends on who you ask if you need this 12 or not, because the idea is it's supposed to be as easy as possible for those producing the part and running the machines to do it, so like hopefully they wouldn't have to do any math. But there are a ton of drawings where you do have to do math, so it really just depends on what situation you're in, what your bosses would prefer, or your teacher in this case. But like I said, everything needs to be clear. So on that one drawing we were going over with Mr. Pritchard that one day, and it took us a while to figure out like the counterbore, like what the dimensions of the circles were. That wasn't a good drawing. If you're in industry, like your boss would be mad at you for that, because that could be a really costly mistake in mass production and stuff like that. Number 5, dimensions should be attached to a view that best shows the shape or the feature to be dimensioned. So if you're doing the overall width of the item, it should be like on the front view or the top view. You shouldn't dimension hidden lines or things like that. So if you can see like the whole part of the object from a certain view, then dimension it on that object. If part of the object is hidden behind another aspect or feature, then maybe you shouldn't use that one. See if there's a better place that you can put the dimension. Okay. Overall dimensions should be placed the greatest distance away from the object so that intermediate dimensions can nest closer to the object to avoid crossing extension lines. Extension lines are these that connect the dimension to the object that it's measuring. You basically just don't want to cross those. You want to keep it neat and orderly and stuff like that. So if there's a smaller dimension, it needs to be closer to the object that it's measuring, and the overall dimension is going to be the farthest dimension out. Dimensions should be attached to the only one view. So like I said, that kind of goes along with rule number 1, that they should not be duplicated. The same information should not be given in 2 different places. Never cross dimension lines, we just talked about that. Never cross extension lines. Those are pretty much the same thing as dimension lines. So just make sure that they're not crossing. So like here, like that's fine, but this guy should not be all the way out here. Like that would be like crossing the line. If you guys are paying attention, you can get candy from some of the things that I've said already. Leaders should slope at 30, 45, or 60-degree angles. You can change this depending on what you're doing, but most computers are already preset to have that at like a 45-degree angle, so usually you don't need to change it unless your teacher specifies otherwise. Dimension numbers should be centered between the arrowheads except when using stacked dimensions, and then the numbers should be staggered. So, like I said, your computer is automatically going to center them. The only way to move them is if you intentionally click on it, click on the number specifically, and then move that like wherever you want it in the dimension. When it's talking about stacked dimensions, I guess this is an example of a stacked dimension at the very top. So see how the 49 is staggered a little bit off from the 75? That's just to make sure that there's no confusion and that there's clarification on what's actually being measured and what dimension goes with which thing. In general, a circle is dimensioned by its diameter. So, like you can see that circle is dimensioned by its diameter. When you're doing your drawings and stuff, you click dimension your circle. You have the option for diameter or radius. Typically, you should be using the diameter. And arcs are generally dimensioned by their radius. And you can see that on this picture. This circle has its diameter, and when you're measuring circles, if you use the diameter, it's going to be a circle with a line all the way through. And if you're doing the radius, it's going to be signified by an R. Holes should be located by their center lines. Mr. Pritchard already has you all doing that. You have center lines. That's what you draw your dimensions to. That's what they're there for. Holes should be located in the view that best shows the feature of the circle. So like I was saying, if you were doing like a top, front, side view, you would not want to dimension this hole from the side view. Extension lines start approximately 1/16 from the object and extend an eighth past the last dimension. So I don't know if there's any examples of a dimension line up here. So like the closest thing that could be is, see that 5 up there? Everybody see it? You see how it's pretty squished in there? And if you had like 2 numbers there, if it was like a 25 or like a 0.25, if it was like even smaller, what an extension line would be is if you click on the number and you move it out past like the actual measurement line, that would be like the extension line with the number, so you can actually see the number so that it's clear, so there's no confusion on what the number actually is. And that's what it's talking about. So it's going to start approximately 1/16 from the object. So like you're going to have that dimension pretty close to the object, and then it's going to extend like an eighth past the dimension, like an eighth of an inch. So it's going to be close to the dimension that it's measuring, so there's no confusion as to where that number belongs or what it's pointing to, stuff like that. And then there's 2 more on the back. We're almost done, and then we'll get to the fun stuff. The first dimension is approximately 1/2 inch from the object and spaced uniformly 3/8 of an inch apart. So the reason that the first dimension is going to be at 1/2 inch away from the object is just so that you can clearly see the object and what the finished project is supposed to look like. And then the 3/8 off of that is just so that it's uniform and it's clear and it looks nice and basically just for aesthetics. Always dimension the actual size of the object, not the scaled size. So if this like was 63 inches right there, like this is clearly not a 63-inch like object. So what the person did is that they drew the object in the normal scale and they dimensioned it and then they scaled it down so that it would fit on a piece of paper. Does that make sense? Like you always want the actual numbers, not the scaled version, because like we said, we're not trying to make the people that have to read these drawings do any extra work or make their job more difficult than it is. So is there any questions on any of these rules? Is anything unclear? Okay, so now what we're going to do pretty much is, so like how I gave examples, how, like for instance, when I said like if you're measuring a circle, like the diameter, it's measured by like the diameter, not the radius. So if I came up here and I was like, well this rule says this and it's followed on this drawing because it's like measured by diameter, like then you get a piece of candy. It's basically just showing that you understand like why this drawing is the way it is and you're able to apply the rules that we just went over. Does that make sense? Or if you think that something's wrong, like there's a rule that says like you're not supposed to dimension inside the object. If you think that any of this is wrong or you question any of this or you understand like why it's like that or don't understand, like feel free to ask, and if you have questions you'll get candy too. So, does that make sense?
So I'll have to take it. go? Are we supposed to raise our hand?
Yeah. Go for it. What do you got? You can come up here too so your classmates know what you're talking about.
Oh, come on.
Yeah, and then we'll talk about it this way. Sorry, you just asked the question.
On number one, it says, it's like 2 ways. And this right here, it's like, you just add all these up, that's 45, but it's telling you it's 45, like, you don't need this.
Okay, we can go with that. You can pick whatever you want out of there. Only take one.
Sorry. Thank you.
Who's next? Is there anybody else yet? Maybe not so much that it's because it's here, but it's unnecessary because it's
Okay.
there. So yeah. So basically what she was saying is she thought that this dimension right here is considered unnecessary because there's also a dimension here that says 10. The reason that this one is necessary is because it's telling you that the center point is 10 inches from the left corner, but this is telling you that it's up 10 inches. So this is right 10 inches, but just because it's right 10 inches did not necessarily mean that it's up 10 inches. So, but yeah. So because of that, because she tried, she still gets candy. That was actually a really good question. Okay, here we go.
Is this the side view?
This is if you're looking down on it.
I know, I changed my mind.
Yeah.
You can see that the diameter of the circle is 10, and that's the most obvious view of the circle, and it's better represented there.
Okay. Come here, candy. Did everybody hear what he said?
That's the best view of the circle.
So he asked like which view this was. First off, he asked if it was the front, side, or top. And I would guess that this is the top view, just from like what I know. And he said, well, since it's the front view and you see the front of the circle clearly, that this circle is best dimensioned in the front view. Does that make sense to everybody? Because you can see the circle, like the entire circle head on. You're not seeing any hidden lines. You're not seeing a fraction of the circle. You see the whole thing. So it's the best view to dimension it in. Yes?
At that point, by 100, doesn't those lines cross which are not allowed to?
Come show me.
Like, that over there,
What lines are crossing?
the 100 and this. And then where that one's facing, that line's crossing.
Yep. Did everybody hear what he said?
Is that 75 there necessary?
It is necessary.
Or
Well, actually,
because look, there's a 12 right there that shows that.
okay, that's a good point. No, it's not, but the reason that it has these overall dimensions is just, like I said, so that they don't have to do any extra math when reading the diagram that they're reading. Does that make sense? So like I said, that's up to interpretation, just depending on the bosses and personal preferences of company to company. Yes?
That number 5 is like too tight inside that space. It needs to come out.
Okay, we can go with that.
That's what I was gonna say. I hate you. I was making sure it was right with Taylor.
He's literally saying everything you said.
I'm so mad. That's
I wasn't paying attention, at least he was paying attention.
So mad.
That's a good thing.
I was asking Taylor to make sure I was right. I was so mad.
Pay attention, that's what she said. She said
I knew that.
She said she's trying to tell us the
I
answer.
listened.
If you knew it, then why didn't you raise your hand?
I literally heard you say extend the 5 out so you can see the number better.
Why
That's
didn't you
exactly
just
what
say
you
it?
said.
I was literally just gonna say it.
Okay,
I'm not going to
okay,
repeat what you
moving
said
on.
because
No.
you already said it. So technically you already said it, so I shouldn't.
Moving on, everybody listening?
Yeah.
Thank you.
Is the
45 dimension, does it need to be there since you have 12, 11, and 22?
Show me. Right here.
No, other way. On the side.
That one was already stated.
Was it really?
I'm pretty sure that's
I
the very
did.
first one we
Did you really?
covered. Yep. Try again though, for sure. You will still get a piece of cake. Anybody else? Yes.
No. It says that this line stops, but is that even really necessary? to say that it stops?
We're all just asking, is this necessary? Is this necessary? Is this
The
necessary?
notes.
Well, I mean, like saying that, I mean, obviously it stops.
We're not necessarily talking about the notes per se. The notes are just to make sure that things are clear. We're mostly talking about just the dimensioning for now. But yeah, you can go ahead and get a piece of candy for trying. But let's move on to like some other rules. Try rules that haven't been covered yet.
I got one.
Yes.
Technically, you could argue that the 135 angular dimension is not necessary because you have two 12s and the 12 is a square and it cuts into half. And you know that half of a square is 45.
Okay. I like that a lot. That is actually a really good point. You can
Go
get
ahead.
2 for that. That was
Yeah.
impressive.
Why?
Okay, so what he's saying is that this dimension is technically not necessary because he used geometry skills, which in more advanced drawings you will have to use, and you'll even have to use trigonometry too in some of them. But, so what he's saying is because this distance is 12, and this distance is 12, then that makes this a special right triangle of 45, 45, 90, which means, like, okay, so since this distance is 12 and this distance is 12, then that means it's a right triangle. This would be the hypotenuse, it would be a special right, and that would make it a 45, 45, 90. So that means this angle right here is 45 degrees. And you can figure that out by knowing that these two distances are equal. So you do not actually need the 135 right there.
Harry,
Whoa.
you're supposed to help me.
That was a good one.
That's good.
Technically, also concerning this dimension, you could argue whether or not the 135 should or should not be inside the object. Because you could measure this distance and show that it's 45 instead of doing what he did, and then you could put this like out here. The reason that this is on the inside is because it makes it neater because there's so much going on in this area, and it would be cluttered and hard to follow what lines are pointing to what. Did everybody follow what he did? Okay.
That's impressive, dude.
That was pretty impressive.
Gabby, do you see anything? No? Nothing?
Mine just was
Remember,
incorrect.
She's so
Mine just was incorrect.
What about Maddie? Do you see anything? No? Do you even want to try? Do you have any questions? No?
You skip.
She said if we can explain what's
Ryan?
the center line
That's Chris.
in the middle of
That's
the
Chris.
circle.
What?
Because that's a
Oh,
circle.
Okay, what do you see?
I'm sorry, I was
Okay, back to you.
Are we just supposed to direct it or something?
You can point out like things that like follow directions too. Like it could be like correcting, it could be
The
questioning.
leader lines are supposed to be 45 degrees or set like that. And the only way you can change it, you can change it specifically. Because I don't know.
I like that. You can get some candy.
Oh, yeah.
Yes,
Did we already say something about the center lines with the circle?
we did not.
Okay, so like holes should be center, like located by their center lines. So the crossing center lines that are in there are right?
Yes,
Okay.
correct. So what she's saying is that holes are supposed to be dimensioned by their center lines, and she's saying that this picture followed it because the center mark is 10 inches up and 10 inches over from, does everybody see that? Does that make sense? You can come get candy.
I told you that.
I was zoned.
I said it. I said it. She was like, sorry, I was zoned. I
That's
didn't hear
what I
you
was
said.
thinking about.
She took what I said to her.
Did
That's
you
what I was
raise
thinking.
your hand? Did you raise your hand?
You're like, I'm zoned. I didn't hear you.
That's what I was thinking about.
Yeah, I was so mad.
Back to you, I guess.
Thank you.
Yeah.
I'll find one for you.
These two right here.
Come up here so
Oh
everybody
my
can
god.
I have two.
Spencer needs to stop.
I don't think Spencer should be
see.
on.
Everybody else needs to raise their hand then. It's okay to be
I'm
wrong.
trying.
You still get candy if you're wrong. It's the effort that we're looking for here.
Well, in that case.
You don't need that 75 up there because this already tells you.
I
already said that.
Okay, I got no one.
I need this 10.
I already said that.
Sure. Yeah, sure.
Pay attention. I was just talking about the center of that.
That
No,
first
she's
time
the
I
first
did
time
it, I
she
said
did it.
it
The
tense.
second time, that was her second one that we just talked about.
Okay.
Go sit down, what do you think?
Pay attention next time.
Yes.
Chris, you ain't even answer one.
You need, I ain't got this.
Exactly.
Come show everybody up here.
You already answered all the dumb ones when I need to answer for. Do you need this overall measurement?
We discussed that. I guess we discussed that particular measurement for a few different times, but not particularly in regards to this. So you would not technically, but the reason that we have this overall dimension is just so they don't have to do this little math. So it's just like easy, like to agree. Does that make sense? You can get it. What about dimensioning an arc? Sarah.
So
The
she's
arc
going for it.
is measured by
R10, radius 10.
Okay, perfect.
Yes. I was like, I swear.
So what she's saying is that this arc followed the dimensioning rules because it's dimensioned by its radius and not its diameter, specifically because arcs are dimensioned by their radius and circles are dimensioned by their diameter.
So then we point out like it's stuff that follows the strong.
Yeah.
Alright, well then, does not present any hidden lines.
You're welcome.
At all.
Perfect. So a really good point that he made is that this drawing does not present any hidden lines, which that's not so much important as the fact that there are no hidden lines dimensioned. You never want to dimension from a hidden line to like an object line, if at all possible. Like you always want to dimension with just object lines so that it's clear and concise and it's very clear what you're dimensioning. Because sometimes hidden lines are hard to interpret. And they're hard to measure once the object is fully constructed, if that makes sense.
So then we insert the hidden lines after it's dimensioned?
No, just don't dimension from hidden lines.
Well, holes should be located by their center.
I said that.
Harrison?
Oh, I didn't. Well, I was gonna ask, what's the point of like the gap, the 15 and 12 millimeter gap measurement? at the top
Harry
of
just has like all the candy over there.
that? You see?
I do see.
What's the point of that?
1 millimeter gap.
I do not know, to be honest. I don't know what the top left corner is. Does everybody see what he's talking about? At the very top, it has a 15 millimeter gap, a 12 millimeter gap, and then a 100 that's like just extended over, not towards anything really. I don't know what any of that's for.
100 too at the top.
Right, yep, that's what we just said. And it specifically says on the drawing that the dimension is not complete. So I don't know if this drawing wasn't finished but that is something that's ambiguous and you do not want any ambiguity on any finished products or drawings. So that's something that's wrong, so you can get candies. Yes,
I have a question.
I hopefully have an answer.
Where it has that 40 plus or minus, do you want me to come up?
Yeah.
Okay. So where it has this like this 40 plus minus,
Mhm.
what is this? What is that? It says like 0.5 at 45 degrees.
I think what that's talking about is if you look at that top edge, it looks like it's rounded, but just barely. So with the scale of this drawing, it's probably like a 1/2 inch fillet, which just means that the corner is rounded. What a fillet is, will you hold this up for me? Okay, I think everybody can see this. So what a fillet is if you have a block of wood, that's a typical block of wood. If you round over this edge using like a router profile or something, and this is no longer there, that's called a fillet. So what I'm assuming is that because this drawing is so massive, like you got 63 inches here, 75 inches there, and it had to be scaled down to fit on a piece of paper, the ink probably makes it look like that's a solid edge, like down here, but what this is letting you know is that there's actually a 1/2 inch rounded edge right there. and it's 45 degrees, so that's basically just telling you how to set everything up. Can you move your mouse, please? Sorry.
Mine's fine.
Yep. And that would be the equivalent of measuring it by the radius. That was a very good catch. You can get some candy.
Or you can ask me the question.
Is that
Anyone else? Anything else?
Insurance got one.
Something that could be said that's like wrong with this drawing is that these two dimensions are not lined up and that this dimension is on the same dimension line as this. The overall dimension, like I said, is supposed to be farther out than any of the inner dimensions. And it's supposed to be separate, if that makes sense. Yes.
What's 10 plate mean?
That's probably saying like what type of material to use.
So I like the
Yeah. Yeah. Is there anything else that anybody else sees that has been followed or not followed?
The projection line, it says up there,
Mhm.
the projection line thin, pretty much just says that projection line is not the drawing line.
Yep.
It's just a-
Yep. Yep, you can get candy for that. So basically what he's saying is that this is just making, that note up there is just making sure that everything's clear on the drawing, and it's specifying that this thinner line right here is a projection line, and it's like thin and it's like separate from the object line, so there's like that confusion. Anything else you think needs hit on?
I have a question for you, Rachel. By the way, you did a very nice job, because it's hard to keep people interested in this. You guys watch this, because I bet, I'm be willing to bet, and I hate to say this, I think Harrison Kill might be the only one that can figure this out.
Wow.
How do I draw this arc?
Okay.
No, wait, stop, let me show you something. Because it's over 10 from here to here. How do I figure out how to draw that arc?
Well, I know now because you told me yesterday, but I want to know it if you didn't tell me.
You guys see what I'm saying?
It's a radius dimension.
I know how to do it, but I don't know how to explain it.
Because it's not, you can't just measure and put an X and say, okay, I'm doing it right there. There's a certain procedure, and I think you do know, because I showed you the other day how to do it.
That's what I was going to say.
You guys watch this, and before I explain it, I want you to kind of think a little bit about it, okay? You know where this line's at, okay? And you can figure out where this is at. You're with me so far, right, Gabby? You're not with me. But let's bounce here and lead you astray. Here and here. Once I have that little X drawn, then I know the arc is how far away from each line. 10, right? And then I can do my tangent, go tangent, tangent, radius. And that's how I would draw it. The other thing I want to point out is, you know, a lot of you guys, like I heard you say, well, you don't need this overall measurement because you have the other ones. If you have an option, you always want the overall measurement because it's like anything else. Like if you're going to buy a TV for your house, you don't want to look at a drawing and go, okay, if I had this and this and this, okay, it's 38 inches long. It won't fit underneath the counter. You want to know the overall measurements. But she covered, I mean, it seems simple and there's a lot of them, but at the same time, that's kind of it. That's like the whole ball of wax. Everything kind of branches off those, but that's all there is to dimension. And, you know, it's kind of like cars used to be. They made cars so you could drive them. They were very simple, nothing broke, but they got the job done and you knew what you were getting. Now we have all the bells and whistles and all kinds of stuff goes wrong. Yeah.
So you're going to go from that top line, measure over 10, measure 10
No,
down.
because this is not 10. I mean, look, we have 10 right here, correct? This is 49, correct?
Yeah.
So if we start there, we end up right here, correct?
Yeah.
How long is the whole thing? Look, now don't look down here, look up here. See 75 up here?
Yeah.
So we have 10 plus 49, that's 59. So we actually have almost 20 left over.
Correct.
You see what I'm saying?
Yeah. I That's hard.
Well, it's not, but it's one of those things that makes you think. And anytime you can think, you're getting better. Here's what you messed up.
Thank you. Who did not get a piece of candy? Raise your hand.
I just had to answer your question.
Seriously?
Everyone who did not, everyone who did not get a piece of candy.